Tell me if I run out of juice today, or run out of memory. I can write vectors as ordered pairs, find their magnitude and direction. So the first problem that we're going to do is this one. Given a vector, -6, 8, let's find the magnitude and direction of that vector. Okay? Given the vector, -6, 8, find the magnitude and direction of that vector. Given a vector, -6, 8, find the magnitude and direction of that vector. Given a vector, -6, 8, let's find the magnitude and direction of that vector. When you see -6, 8 inside there, remember that's the identification for it being a vector. The -6 and the 8 represent what of the vector? The x and the y, horizontal and vertical components, however you want to say. Okay? You can draw this vector however you want. You don't need to draw it to scale. All right? You don't need to get out graph paper and make sure it's going -6 in the x direction, 8 in the y direction. You can just label your picture correctly. Okay? But if I wanted to do it exactly right, all right, I'm going to start down here. So I'm going to call that my starting point. And to draw a vector -6, 8, I got to make sure the vector goes -6, 6 in the x direction, and 1, 2, 3, 4, 5, 6, 7, 8 in the y direction. And if you want, again, you don't have to make it to scale, but do please at least label it so you know how long each side is. Okay? So -6 is the horizontal component, +8 is the vertical component of the vector. We want to know the magnitude and direction. What is magnitude again? Length, the distance, okay, the force, okay, if it represents a force of some sort. Alright, so in that case we would just need to find the what? Hypotenuse, okay? All you got to do is find the length of the hypotenuse using Pythagorean's theorem because we have a right triangle, okay? So -6 squared is 36, 8 squared is 64, so we got 36 plus 64 equals c squared. That's 100 equals c squared, so c is 10, right?
Yep.
Right? So your magnitude is 10 units. All right, I didn't really give you a specific label in this one. All right, but 10 units. The direction, okay? The direction is going to be represented by a what? Or by an angle. All right. This angle could be labeled any of about 3 different ways. Right? You're going to be able to give it an angle measurement. If this is 0 degrees, it looks like, maybe it's going to be somewhere around 110. So you can just label it at about 110 degrees. We'll figure it out here exactly in a second. Or you could label it, if you know this amount right here, you could label it so many degrees west of north. Or if you know this one right here, which is probably the way that a lot of you are going to go, when you find this angle right here, you could label it so many degrees north of west. Yep. Okay? So any of those 3 ways is going to be fine. So in this case, this is the angle we should be able to find the measure of. What would we use to find, I'll call it theta for right now. What would we use to find theta? Derek?
Inverse sine of
Inverse sine of 8 over 10. Perfectly fine, because we know that's 10 now. All right. What if we didn't have that 10, or that was a crazy long decimal, and we didn't want to write that crazy long decimal? Inverse tangent. Okay. All right. So, in case I ever just ask for the direction too, I don't ask for the magnitude. Don't feel like you have to figure out the hypotenuse and then use inverse sine. Yeah. Understand, you can use inverse tangent right away. Because the tangent of theta would equal negative 8 over 6. So theta would equal the inverse tangent of negative 8 over 6. So I need a little help from calculators right now from you guys. And you're going to get kind of a weird answer, but we can make it make sense for us. What does your calculator say the answer is? To the nearest tenth.
53.1.
Negative?
Yeah.
It says negative 53.1, doesn't it?
Yeah, negative 53.1.
Okay. It says negative 53.1. Okay. Here's why. Okay. It is negative 8/6. Here's why it's saying that. You're telling the calculator that some angle has a tangent of a negative 8 over 6, or negative 4/3. Okay? Well, in what quadrants does tangent have a negative value? 2 and 4, right? 2 and 4 is where tangent has a negative value. The calculator always gives you an answer in quadrants 4 or 1 for tangent. Just because that's closest to 0. Quadrant 4 is close to 0, quadrant 1 is close to 0. The calculator just gives you one answer. Because remember, how many angles would have a tangent value of negative 8 over 6? How many possible angles, how many possible answers are there in the world? Infinite. Okay? Whatever it is in quadrant 2, and then in quadrant 4, and then go around again, quadrant 2, quadrant 4, quadrant 2, quadrant 4. There are a ton of answers for this. The calculator just gives you the one that's either in quadrant 1 or 4, because then they figure you can figure out what the other ones would be. Okay? So the calculator is saying a negative 53.1 degrees, so negative 53.1 right down here, has a tangent of negative 8/6. Well, we can ignore the negative sign, alright, because we're really just trying to figure out what that reference angle is. And what's the reference angle of a negative 53.1 degree angle? 53.1 degrees. Okay, so this angle right here is 53.1. Alright, so this right here is 53.1 degrees. So you're really going to be able to make it positive all the time, even if your calculator tells you negative. Okay? Now, to write our answer, I'm going to say the magnitude is 10 units at, let's do all three answers. Which one would you probably use, Jake?
I'd probably do the north of west.
So 53.1 degrees north of west. Okay? So 53.1 degrees north of west. You must put of in there. You cannot put northwest. Northwest is only for exactly a 45 degree angle. Okay?
If we get a 45, can we?
If you get a 45, you can write northwest, southwest, southeast, whatever. That, absolutely, because I'm going to, when I see southeast, I'm going to assume you mean a 45 degree angle down there in the fourth quadrant for southeast. Drew?
If you use 53.1, wouldn't it have to be north of west?
Has to be, yes. Yep.
Unless you, like, figured out one of the other angles.
Yeah. Mm-hmm. Yep. The other two answers we're going to figure out will not have a 53.1 in them. Absolutely. Yep. Derek?
There's 37. That was a point one, sorry. The 36.9 degrees west of north.
West of north. Okay. 36.9 degrees west of north would also work. Because if this is 53.1, then that part right there is 36.9. 36.9 degrees to the west of where north is. If here's north, I got to go 36.9 degrees west of it to get to my vector. Okay?
Like 126.9.
So if I take 90 plus 36.9, that gives me 126.9, no label required then. Okay, just 126.9 degrees. Okay? I don't care. They're all good. They're the same. They're coterminal. Okay? They're exactly the same. I would accept either of those. Obviously, which one takes probably the least amount of even thinking or math? Well, use the one that you find right there in the triangle. Some people struggle with directions. So some people don't want to have to worry about directions and actually even figure out what it would be starting from 0 to 90 to 180 to 270 and so on. They're all the same. They're all coterminal. All right. Questions on this type of problem? So if I give you a vector, can you find magnitude and direction?
Yes.
Feel good about that. Awesome. Okay. Next type of problem. Make you think a little bit about a coordinate plane here.
That's right.
I will. Yeah.
If you like square root the, try to find the hypotenuse, you like square root it, it doesn't come out like perfect. You want us to leave it as a square root or try to round it?
Depending on the directions.
Okay.
To help you go further, I might leave it in square root to help you do the math further on with it. But if the answer does say, or the question says round it to the nearest hundredth, then do that, or tenth, or whatever, when you write your final answer. Negative 3,5, 4, negative 2. Negative 3,5, 4, negative 2. What number? Negative 3,5, 4, negative 2. I'm going to summarize those directions from the notes that were there. Okay. They might give you a starting coordinate of a vector and an ending coordinate of a vector, and ask you to write the vector as an ordered pair. Some of you are going to find this very simple. Okay? Write vector xy as an ordered pair. If they put it this notation right here, xy, that means x is the starting point of the vector, and y is where the tip of the arrow would be, or the end of the vector would be. Okay? Some of you are going to be able to look at this and say, well, if I'm starting here, and I'm going here, well, how far did I travel in the x direction? If I started at negative 3 and ended up at positive 4, how far did I travel in the x direction? 7 units. There's the first part of your answer. Okay? If I started here for a y value and ended here for a y value, how far did I travel in the y direction? Negative 7 units. I'm saying how far, although if you thought about it on a graph, you would be headed down. So make sure you're as you write your answer, you're writing it as a how far you travel horizontally and vertically, and that could include negatives. Okay. So the answer is going to be 7, negative 7. All right. But if you can't visualize that, that's fine. Okay. Just get out a sheet of graph paper. Negative 3, 5. That's right here. There's x. 4, negative 2. There's y. This was my starting point. Y is my ending point. There is my vector right there. That is the vector xy. Okay? If you write it as an ordered pair, you just need to think, okay, how far did I travel in the x direction, comma, how far did I travel in the y direction? Well, I went 1, 2, 3, 4, 5, 6. I went 7 this way. And I went 1, 2, 3, 4, 5, 6, 7 down, so that'd be negative 7. Okay? So if I were to write this vector as an ordered pair, very simply my answer is 7, negative 7. And that would be it. You don't need the picture to help you. Alright? If I asked you to find the magnitude of that vector, well,